Hello, everyone, and welcome to our session titled Enrichment, Better Data In, Better Response Times Out. My name is Sean Cannon. I'm a threat management consultant at Aflac. I have over 26 years of IT experience working in systems administration, client hardware implementations, managed security services, and big data. Right now, my focus is on managing our SIEM environment, which is Splunk, and the AWS environment that Splunk lives in. I'm also working to bring in new data as needed and improving that ingestion process. Carly, tell us a little bit about you.
Sure. Thanks, Sean. Hi, everyone. My name is Carly Rosado, and I'm a solutions engineer at Cribl. I've been with the company for just over 2.5 years. Prior to joining Cribl, I worked in the IT operations organization at Citibank, where I was responsible for logging and monitoring all of the infrastructure platforms. So you can think Linux, Windows, container environments, virtual machines. But now at Cribl, I can take my practitioner experience and help teams deploy strategic logging solutions in their organizations. So Sean, let's dive right in. Can you tell us a little bit about the data challenge you were facing at Aflac that prompted you to look into Cribl Stream?
Sure. We decided to look into Cribl Stream initially as a replacement for our antiquated syslog solution. After a huge success with that, we implemented the following things over a 2-year period. We moved our HTTP event collector for our AWS sources over to Cribl Stream. We moved a lot of script collectors that we were running on Splunk heavy forwarders over to Cribl Stream as well, and converted some of those to REST collectors. We are a CrowdStrike customer, so we are bringing in CrowdStrike's FDR data using Cribl Stream, and multiple S3 sources from AWS, CloudTrail, CloudFront, and Capsula, that sort of data. And we also had a need to fix certain data coming in that had JSON and non-JSON mixed together. So we used some pipelines and functions to meet that need, which is much easier to manage than trying to do a lot of props and transforms on the Splunk side. So we're able to join JSON key pairs in the searchable fields before sending the data to Splunk. And there's a lot more that we've done that I just don't have time to go over right now. So here's our challenge that we really are basing this session off of. We needed a solution to use a lookup file that has approximately 34 million rows in Splunk. As you can imagine, a lookup file of that size, trying to search and add that into a Splunk search, that's pretty much impossible. A third-party solution was initially chosen by one of our teams at Aflac that utilizes Cribl, but using a Mongo database. But the annual cost of that third-party tool was just a little bit too much for just this one use case. So I needed to come up with a solution to replace that paid third-party solution that worked just as fast with a lower cost. So Carly, give us a little bit of information about what we can do with Cribl.
Yeah, thanks for that background. So I do just want to highlight that from a Cribl perspective, there are a few different options when it comes to enriching events as they stream through the Cribl platform. So one option is using local lookups or CSV files. So these files can be loaded onto your stream leader and updated manually or via a script. And some ideal use cases for CSV lookups include data that doesn't change regularly. So the data is more consistent, more constant. It requires less maintenance and upkeep. And you should also consider the size of the file since it's hosted locally. The larger the file, the more resources that will be required on your Cribl infrastructure for processing that data. So you may need more memory as your files grow. You may need some additional worker processes to handle that data load as well. If your data feed changes on a regular basis or is larger than a few million rows, we would suggest exploring Redis as a potential option to host the lookup file. Given your problem statement, Sean, I'm assuming the team at Aflac deployed Redis for the additional processing capability?
Yes, that's a very good answer. I did a lot of research into Redis since Cribl Stream has that Redis function. So I ended up creating a Redis Elasticache instance in AWS, and I populated that with the lookup file data and then used the Redis function in Cribl Stream to add the fields we needed. So let me show you how that works. So here's how I configured Redis. In order to create that cache, first, you need to know what size it's going to be. So I referred to the Redis docs, which showed me this. 1 million small key value pairs uses about 85 megs of memory. So if I did my math right, 34 million small key string pairs take about 2.8 gigs of memory. I was able to use the smallest Redis Elasticache instance size, which was cache.r6g.large, which is 2 CPUs and 13 gigs of memory. I'll have plenty of room to grow this Redis if I need to, since it's 13 gigs of memory. Now, I had the CSV file as a backup, so I wasn't really concerned with setting up a Redis cluster, so I opted not to use that in this case. I went with 1 shard and 3 nodes. So there's a primary node and the other 2 as replicas. So how did I get that CSV file into Redis? So this large CSV file is created every morning from a Splunk search. I use a scheduled cron job to ingest the CSV into Redis. Here's an example of the command on the screen that I used, and I did this on my test system, as you can see. But this awk file I'm using, I found online, and if you'd like me to share that with you, you can reach out to me on the Cribl community Slack, and I'll get it to you. Essentially, the AWK command reads the CSV file line by line using the script, using demo as the Redis key, and column 1 of the CSV as my user ID column. As each line is read, it's sent to Redis by piping to Redis CLI. And this demo file I use, you can see it on the right. It's, of course, a lot smaller than my 34 million record file. But you can see each record gets stored in the Redis format of demo:account number. Like I said, the example is on the right.
This sounds like a great solution to programmatically collect and write the data to Redis. However, there is another option for individuals less familiar or less comfortable with scripting solutions on their own. So as an alternative to writing the data to Redis via a script, you could write the data to Redis using inline functions available in Cribl Stream by default. So Stream supports almost all Redis commands out of the box, with most read and write capabilities covered and available. So Sean, potentially a phase 2 or enhancement to your existing solution, we could work together to update the pipelines to remove some of the additional steps and extra technical components from your workflow.
Yes, that sounds excellent. So today, as you can see, what I'm doing is I'm using a Redis function, like Carly mentioned, in Cribl Stream. But in this case, I'm using the get commands to be able to pull that data from Redis. So what I need is customer ID field is going to pass through a pipeline that calls the Redis function. This is going to take the account number field in the data and match it to the key in Redis, and then Redis is going to return the customer ID field that I need. So here's an example of what the data looks like as it's coming in before the Redis function is applied. You got the account number there, the name. There's obviously going to be more information than this, but in my demo system, this is what you would see. We'll show the index, the source type it's going to go to. After Redis, you can see it's adding a customer ID, which is got matched to the account number. It pulls that data from Redis. And that's pretty much as simple as it is. I mean, it's remember, Redis is a database in memory, so it's going to be fairly fast, but the fast depends on where your Redis is located and where your Cribl workers are located. So if everything's in AWS, obviously it's going to be pretty fast, but if you have this running from a Cribl worker that might be in a different location, you will have some latency to deal with, so just keep that in mind.
Yeah, I was actually just going to ask you about that because we often get questions around latency as you're building out and streaming data through the Cribl pipelines. And Stream offers a pipeline profiler feature within the UI where end users can review the amount of time it takes for events to be processed by each of the functions. This will help individuals identify bottlenecks or if any latency exists. So just curious, Sean, in your environment, were you able to use the pipeline profiler for your Redis function?
I was, and because our workers actually exist in a different data center, there is some latency there, but it was expected. So it's something that it is nice to see that you can look into that and get an idea of what that latency would be. But in our case, even though the latency might have been, in 3 or 4 seconds, that was acceptable for us.
Awesome. Thank you for sharing that solution. We're glad Cribl Stream has been able to provide operational value over at Aflac. But for many, Redis is a bit intimidating at first. So we wanted to spend a few minutes discussing some of the more technical topics and options as you deploy Redis alongside Cribl Stream. So when you're setting up Redis, you have different deployment options that Sean touched on earlier, depending on the complexity of your environment. So you can run a standalone, clustered, or Sentinel mode. Sentinel mode really just means there's a backup copy of each record stored. And there's no harm in starting simple. So as you build out your use case, and then you can add additional functionality, once you're ready to move some of those use cases to production, you can continue to build on your standalone environment. The next item to determine will be where is the best location to run your Redis instance. So Sean touched on this a few times as well in his presentation and when he was setting up his Redis cluster, but it's important to keep in mind the location of the Redis deployment in relation to the worker group that will be retrieving the data for enrichment. So how long will it take to traverse the network to collect the information for enrichment? And then there are a few advanced settings that can be tweaked within Stream to enhance the functionality and reliability of Redis and its interactions with the Stream platform. So the first one we touched on a little bit were the basic commands. So by default, there's a drop down within the Redis function, which lists a series of commands that are available for Redis. But a little cheat code and hack is that you can actually manually input commands into this box as well. So you're not structured or confined to the ones that are listed there. And then two settings that you can choose to alter are for caching and timeouts. So caching can lead to better performance when we're able to minimize the number of calls to Redis. So if we keep the key and store it in memory, we need less calls out to the Redis environment. And then the last option, timeouts, helps us ensure that data is not halted or missed if Redis is unavailable. So Stream will wait for the period of time that we set as the timeout. And if we don't receive a signal back from Redis, it will continue to process the events through the rest of the pipeline and send them downstream. Just one word of caution here is to be mindful of what you set for your timeout value, as Cribl Stream will wait that entire time before it will continue to send events downstream. So there may be some latency if it's waiting on Redis for an extended period of time before you see those events hit your downstream destination. And then last but not least, we wanted to leave everyone with a few resources to help you get up and running on your Redis journey. The first and probably most useful is the Redis pack, which is out on our Cribl pack dispensary. If you're not familiar with Cribl packs, they're pre-built content, so pipelines and sample data. In the Redis pack, you'll get a series of sample use cases around aggregating, quota enforcement, and enriching data, similar to Sean's use case. And then there are also a series of links on the right-hand side around blogs and configuration files to help you get up and running with the Redis use cases you're brainstorming now.
Thank you so much for watching our presentation. I hope you got something useful out of it.
And Sean, I want to thank you from the Cribl team. So not only being a Cribl customer, but also joining us for our first ever CriblCon and sharing your solution with the audience.